Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 1. Let's get started. Okay, today we're going to be talking about taking sentences and writing them in symbolic language. So writing symbols is simpler than writing in words, and as long as everyone understands what the symbols mean, then it makes things much easier. Can you imagine trying to do mathematical operations with a sentence rather than an equation? So this lesson focuses on accurately just transcribing written statements into mathematical symbols. And when we write mathematical statements using letters, we say that we are using symbolic language. So we're going to be turning the written word, like a story problem, into symbolic language in the form of an equation. All the mathematical statements in this lesson are equations, and remember, equations are a statement of equality between two expressions. So equations have equal signs, and we're going to develop those equations from the written statements that we see. Okay, so let's get started and try a few exercises. Number 1, the sum of 4 consecutive even integers is negative 28. Well, the first step here is to decide what is our unknown. What is it that we don't know? And the first thing I think of is I don't know what the first even integer is. So I don't know what that is. So let's call it something. Let's assign a variable. I'll just use x. X is the first even, that's a v, even integers. So whatever that happens to be, we'll be able to figure that out later in the unit. But right now we just need to write an equation saying what this sentence is saying. So I've got some keywords here. Sum. That is the answer to an addition problem. So I know there's going to be adding going on. So I'm going to start with my first even integer, x, and I'm going to add to that my second even integer. Remember, I have 4 of them. So my second even integer would be whatever x is plus 2, because remember, evens are every other number. So x plus 2 would have to be x plus 2. That's my second even integer, and my next even integer would be x plus 4, and my last even integer would be x plus 6. So I have, let's say, for example, x is let's say that x is a 2. Well, 2 plus 2 would be 4, and 2 plus 4 would be 6, and 2 plus 6 would be 8, and that gives us 4 consecutive even integers. So my expression so far works. All right, and then it says that it is or equals negative 28, and there is our equation. Now we could use algebra skills to find out what those are, and those we'll definitely be doing later in the unit. All right, but for right now, that's our job. Write an equation using symbolic language to match the statement. Okay, number 2. A number is 4 times larger than the square of half the number. Okay, a little confusing, but let's start with what we don't know. We don't know the number. We have no idea what that is. So I'm going to call that, this time I'll call it z. Z is a number. Whatever that might be, who knows, but it's a number. So I'm going to use that variable in place of whenever I would use a number. A number is, well, that says z equals. Is means equals. A number is 4 times larger than this, the square of half the number. The square of half the number. So I'm going to take half the number, so that would be z divided by 2, and then I'm going to square it like this. So let's check it and see where we're at. a number is, so z equals, that's good. And then we have 4 times is right here, 4 times larger than something. And the something is the square of half the number, whatever it was. So half the number is here, that's half the number. And then you can see that we have the square there. So there's the square part. Z equals 4 times the quantity z divided by 2 squared. All right. Exercise 3. Stephen has some money. How much money? I don't know. So I'm going to define my variable. I'm going to call that M equals Steve's money. Steve's money. Okay, so now we have our variable defined. If he spends $9, okay, if I spend $9, that means I'm going to start with Steve's money and I'm going to take away 9. So I've spent $9. Then he will have, so this is going to be equals 3/5 of what he started with. Well, 3/5 of what he started with would be 3/5 times Steve's money. So Steve's money minus $9 is equal to 3/5 of his money to begin with. M minus 9 equals 3/5 M. Okay. Next one, the sum of a number. What number? I don't know. That's my variable. We'll call it N. N equals a number. All right, so there we've defined our variable. Sum means addition. That's the answer to an addition problem. The sum of a number squared, so N squared, and that's where my plus sign goes, 3 less than twice the number. 3 less than twice the number. I have to start with 2 times the number. Twice means 2 times. So 2 times the number. And then 3 less than that would be minus 3. Is means equals 129. N squared plus 2n minus 3 equals 129. All right. Exercise 5. Miriam read a book with an unknown number of pages. Okay, I'm going to stop right there. I'm going to say P equals the number of pages. Number of pages in the book. The first week, she read 5 less than 1/3 of the page. 5 less than 1/3 of the page. So I'm going to, of the pages. So I'm going to say, I'm going to take 1/3 of means multiply. So 1/3 times the number of pages. And I want 5 less. So that's minus 5. The second week, she read 171 more pages. Okay, so we're going to add 171 pages. And she finished the book. So that is equal to P, which is the number of pages of the book. Write an equation that represents the total number of pages in the book. There it is. 1/3 of the pages minus 5 was the first day. So this is the first day, first week, sorry. And the second week, she read 171 pages, and that was the whole book. So when I add the week 1 plus week 2, I get the total. All right, 1/3 P minus 5 plus 171 equals P. All right, that is lesson 1. Hope that helps. See you again next time.